Chapter 1, Part 2 is actually going to start out with this idea of globalization. It used to be back in the day, globalization was really cool because you could actually do a satellite hookup with somebody. It'd take you about 5-10 minutes to actually see the person because there'd be a huge delay. Nowadays, of course, with the world of things like Skype and Twitter and all those other good things that you play with and try to teach your teachers and parents, we can actually video conference. We can actually see what's going on with other countries instantaneously. One thing we do is with Brazil, which has the world's largest rainforest yet, is we keep an eye on the rainforest using satellite technology. Technology, of course, international trade, human mobility allow us to interact. Environmental sustainable development rewards sustainable activities and discourages harmful activities. As I said, we can keep an eye on, even within the United States. We don't want to have another Dust Bowl. So what happens is, and that occurred in the late 1920s, early 30s, we keep an eye on where desertification, for example, is going on and try to avoid it. Resources, you're going to hear me say the word resources 18,364 times during APES. Anything obtained from the environment to meet our needs, anything you need, your basic necessities to live. That does not mean a new iPhone. Natural capital resources, food, water, air, shelter, petroleum. Unfortunately, we are very reliant on things like petroleum. It not only powers our vehicles, but it actually makes things like plastics and all your phones and all your MP3 players, etc. Natural resources, perpetual. If you hear the word perpetual, that means it's continuously renewed, such as solar. Down the road, we'll talk about passive solar energy, which is phenomenal. Open a shade, let some sun in. Perpetual. Renewable must be not to be used up faster than they are able to be replaced, like fresh water and soil. Sustainable yield. Again, you'll hear me say the word sustainable 18,560 times during APES. Highest rate of use of a resource without degradation or depletion. Let's not cut down more trees than can grow in the within our lifetime, because otherwise we're going to deplete those for future generations. In the United States, lumber companies actually, for every tree they cut down, have to replant 2. Environmental degradation, when use of resources exceeds the rate of replacement. We see that a lot with fisheries, for example, the sea bass. Sea bass is actually a fish which is going to be on the extinction list pretty soon because it's really nummy. Tragedy of the Commons came up with a guy named Garrett Hardin. Here's a little picture of a lovely whale slaughter. Overuse or degradation of freely available uses. Ocean pollution is an example. Air pollution. Think of it this way. If it's something we share with other countries or other cities and we ruin it, that is a tragedy of the commons. Think of the commons as maybe our lunchroom, kind of a common area for everybody. What if somebody went in and absolutely destroyed it? That would be terrible. It'd be bad for all of us. The whaling that goes on by Japan is an excellent example of tragedy of the commons. They're reducing our world's whale population for research purposes, which is really interesting. How to protect, limiting use, reducing population, obviously, so we don't need all those resources, converting free access to private ownership. So have land, for example, up by Sorens Ford in Brookfield. The land up there is federally protected because there's blue heron that nest up there. What if we destroy that land? Well, you know what? That's going to destroy the blue heron nesting areas, which is a commons for many of us. So we protect that. Private ownership is oftentimes good if they actually protect it. The thing is, something like air. Canada in the 70s and 80s used to hate us because we would send up huge amount of sulfur into the atmosphere, which would form sulfuric acid droplets, and it would ruin their natural resources up there. That is a commons also. So again, the picture of Garrett Hardin. Ecological footprint, another idea that we're going to take is biologically productive land and water needed to supply renewable resources and absorb waste for each individual. Basically, it's how much to sustain your resources. And of course, in the United States, we are very affluent. In other words, we like our resources and we tend to waste them. We have a very huge ecological footprint as compared to other developed countries such as in Africa, Southeast Asia, where they don't need quite the resources we do to live. Currently, each person's footprint is about 20% greater than what we can sustain. Thankfully, technology has actually extended our ecological footprint. We'll talk about that a little bit more in class. Total ecological footprint, millions of hectares. A hectare is the unit that we'll be using for this. United States is about 25% more than what we should. Again, very affluent. We tend to buy things. Think about your shoes. Do you really need new shoes, or just like the new style of shoes that you're going to get? A lot of countries go with shoes until there are basically no shoes left, and we, and I'm included in that, tend to like our new things, new cars, whatever the case may be. European Union about 19% of the biological capacity, China 18%, India 7% above, and Japan 5%. So quite a bit lower. Per capita ecological footprint, hectares per person, the United States were 9.7, were really huge. Japan 4.8, India way low. If we continue on unsustainable pathways, if you can take a look at right here, we are off the chart, and we're going to ruin our planet. Sustainable living actually reduces that greatly. Non-renewable resources, those that exist in fixed quantity or stock in the Earth's crust. Economically depleted is something we're going to talk about later. When it costs too much to go after coal, for example, after we get the easy stuff, we don't like to go after the harder stuff because it just, the net primary productivity that we get off of it goes down, so it's really not worth economically going after. Oil, coal, natural gas in this area, copper, iron, and aluminum in this also.